All right, here we have two vehicles both pulling a box. The box experiences no friction with the surface. And we have the force that each car is pulling, and we have the mass of each car. And we have the mass of the box. If these vehicles pull the box in for 7 seconds, how far will the box move? So the first thing we realize is the system. What's the system? Well, it all depends on what the question is asking. The question here is asking if the vehicles pulled this box. All right? So the system is going to be the box. So let's see what's happening to the box. First thing we do is we write down what we know. In this problem, we know that the mass of the box is equal to 23 kilograms. We know the force of the truck is equal to 1,734 newtons. And we know the force of the car is equal to 1,654 newtons. All right, the mass of the car and the mass of the truck don't affect this problem at all, because the box, the system, only experiences and only can sense the forces acting on it. You could have a mouse pulling on the box with the same force as the truck, and the box wouldn't know the difference. So those are the only things that we need, except for that time is equal to 7 seconds. All right, in this problem, we're looking for how far would it move. So we're looking for displacement. We know that forces and mass relate to motion by acceleration, so we'll need acceleration first. All right, so we need to draw a free body diagram of the system. So here's the system here. We have the force of the truck pulling to the right. We have the force of the car pulling to the left. So we're going to make the force of the car negative. All right, the force of the truck plus the force of the car is going to equal the net force. So, very simple. The net force is equal to the force of the truck minus the force of the car. Now we know the net force is going to be equal to MA. And it's also equal to the force of the truck, which we know is 1734 newtons minus 1654 newtons. All right. From here, we plug in more information that we know. We know the mass of the box is 23 kilograms. The acceleration right now is the only thing that is unknown. And it equals the difference of 1734 and 1654. So 1734 minus 1654 is equal to 80. So we have a net force of 80 newtons. So simply divide 80 by 23, and we get an acceleration of 3.47. Acceleration equals 3.47 meters per second per second. All right, now we have acceleration as 3.47 meters per second squared. What we're looking for in this problem is displacement. So, in these problems, we need to refer back to last chapter where we connect position, time, and displacement. And we do that with this equation. Displacement is equal to 1/2 a t squared plus initial velocity times time. Now, it doesn't say it, but we can assume that the initial velocity is 0. It's always a good assumption unless you know it. From here, we simply plug stuff in. Delta D equals 1/2 times 3.47. Make sure you write the units. Times a time of 7 seconds squared. So we have 1/2 times 3.47 times 49, and we end up getting 85 meters as our final answer. All right, so there you have it. That's how you solve for the acceleration of a net force problem and then the displacement of a net force problem.